Hello friends, welcome back to my channel. So today in this video we're gonna see how to use Google Earth Engine for exploring the remote sensing satellite data and also how to download it. This video is very different from my other videos earlier I have mostly uploaded the videos related to WebGIS. I will continue to do that, but I thought that I may be putting some other videos regarding some other subject also. So I thought Google Earth Engine is a very good tool uh, these days for exploring the satellite data, for classification, for do the analysis like statistics, graphs, and all that thing. So I found it very useful for exploring the satellite data and download. As if you are from remote sensing or GIS background, you must be knowing the most of our time will go in basically exploring the data, finding the data between the dates, then downloading it, then layer stacking it, and then after that, finally, we do the analysis such as classification or some other kind of NDVI, NDWI, or statistics generation. So all these things. So making the data is basically the longest part. So what we're gonna see today is how to use this Google Earth Engine for quickly. You can very quickly you can explore, search the data, you can composite it, you can create NDVI, you can even download it, and then you can use it further. So this is the basically the layout of the Google Earth Engine, as you can see. So first of all, you need to sign up for this. You go on to the Google account, Google, type Google Earth Engine, then sign up for this. It got activated in the matter of minutes. Then if you open this in Google Earth Engine, there will be two options for JavaScript and Python. So I'm gonna show you how to use using the JavaScript basically. So two kind of platform is there. One can use Python language and one can use JavaScript also. So I'm gonna show you how to use JavaScript one. So this is the basic layout. This is the map. As you can see, you can pan it, zoom it. This is where we will write the code, and in this left one, basically these are our scripts. You can write the script, you can write the program, and you can save it. Like I have saved a lot of scripts, so you can save for the future, and you can also share these scripts with the other person. And second one is here is assets. Here you can upload your shape files or raster files. Like I have uploaded a lot of files. You can click here new, then select either GeoTIFF or shape files or CSV files. So if you click on shape files, like you can select the files, and you can go on your basically drive anywhere like this, and you can select the only. Just make sure do not select .sbx, it will not consider. Like if you select this sbx file, it will say .xbx does not have correct extension. So just skip .sbx file and just open it, give any name. Here you can change this name, and then you can click on upload, so it will upload the shapefile. If you go under the task tab, it is uploading, so it is showing 10%. Okay, so after the this upload is completed, the file will come under this tab. Like I have already uploaded so many shape files. Okay, so now I have already made a script, so I'm gonna show you. This is the script I have saved already. So one by one, line by line, I will explain how to basically what this code is, basically how it works. So first of all, this imports. Import means you can import your asset like this shape file. Suppose I want to import any this is the shape file of Buxar district of Bihar. So what I can do directly, this Buxar, if you move the cursor over the Buxar, you just click on this arrow, so it will import. See this boxer. Okay, I'll do the another, suppose Arwal. I'll click here, so the file has been imported. So I can change the name such as Arwal. So I have imported so many shapefiles. You can import only shapefiles which you want to use. So now the Buxer and Arwal are the name for the Buxer and Arwal shapefiles. So I'll make it, minimize it. So the first line of code is basically you have to see the collection, means, so I have given the variable collection ee.image collection Copernicus. This is for Sentinel data. So Copernicus slash s2 underscore sr means surface reflectance. This is level 2 product. So if you go, you can basically, here you can search, like I'll show you. If you search Sentinel, search it, so level 2, you click here, so you get all the information. This information you get here. You can copy this, and also the description of the bands B1, B2, B3. So we will use that also. So I have just you can just paste it here, that Copernicus S2 underscore SR, and band 2, band 3 I'm taking. Suppose if you want to go for land, you want to go for Landsat, so you can search here Landsat OLI. So you get the Landsat OLI data. So you can basically get the reflectance. Suppose I will click on the reflectance. So you just, if you copy and paste this one here, the collection, so then you will be able to filter the Landsat data. But I'll show you for Sentinel. And here's the name of the band B1, B2, B3. So this is the first line, means then you have to give the date, between which dates you want to filter the data. So suppose I am filtering between 2nd March of 2021 to 5th March of 2021. Filter bounds means, this filter bound means of which area you want to filter. So table 8 means I have already imported so many tables. So what I will do, I will change this name to Buxer, as I have imported this right now. So I will change it here to Bux. This, you have to just give the name of that Buxer. Then print collection means it will print all the images between this and this date. Okay, so then I have created a new variable where mosaic collection, this is the collection dot mosaic, means between these two dates it will mosaic all the data set of this Buxer district basically. And these are the number of band I want to load. I don't want to load all the bands, so I am taking blue, green, red, NIR, and two swirl bands. Then after that clipping, I am clipping it to the Buxer again. It will clip to your area of interest. So after that you can create an NDVI also, like I am computing NDVI. It's very simple, like mosaic dot, you just write normalized differences direct function, then B, give the NIR and the red band. So band 8, band 4. So it will calculate the NDVI. And after that I am scaling it to into 100 plus 100, because if you want to download the NDVI image, if you download the raw NDVI, yeah, you will be able to download, but the size will be very high. As you know, it will directly save as a float or double. It will take more of a space. So I'm just scaling it basically into 100 plus 100. So my 0 will become 100, and NDVI of high 1 become 200. And after that I'm just making it unsigned 8-bit UINT, so that the size of the image will be very smaller. Then I can add the map, this image onto this map. So map.add layer mosaic means this one. Then S2 band, basically I want to NIR false color composite I want to see. So band 8 NIR red, green, and this is the minimum and maximum value of the reflectance. Then for displaying the NDVI, I am just writing this NDVI palette. These are the colors starting to end. This is the hexadecimal colors. Then I am adding the map.add layer, scale NDVI, and minimum value is 100, maximum is 200. Or I can directly visualize the NDVI also. Just you write here between 0 or 1. If I run this code, let me show you what will happen. You just run this code. And also, yes, if you want to export this image, okay, so there is no image between 2 and 5th of, so I'll make it suppose 10. Yeah, now see, this is the Buxar district of Bihar. So there is this for exporting this image also you have to write export.image to drive. So it will upload the image, this image, to your drive. So I am downloading image mosaic, this one, this mosaic, and the scale is means 10 meter pixel, and this table 8 means, so what I have to change to the Buxar, whatever area of interest I want to download here, the Buxar. Maximum pixel you can, it can take, I think 10 to the power 13 is the maximum number of pixel it can download. After that it will divide the whole image into 4 tile. So if after running the code, under the task there is option run. So if you click here, so it will ask you the file name, whatever name you will give. If you run, it will upload this image to your drive. So it has started. So I will cancel it. I will show you I have already downloaded so many images. And also here on the layer you can switch on, switch off, because I have added two layers, NDVI and the layer also. As so you can see, I got the image also here, and I got the NDVI. So in the matter of seconds I will be able to get the image of particular district and also the NDVI. So I can download both things. You can export here, or you can, if you NDVI is this one, NDVI. If you run again, so it has given you two tasks, one for this NDVI, one for this mosaic. So you can download both the things, but I prefer to download the scale NDVI because scale NDVI is much smaller in size compared to the NDVI. So it will not take much of a particular very small area, it will not take much of a time to download to your drive, because even for the states such as Punjab and Haryana, I was able to download in a matter of hours, I think 1 or 2 hours. But in case of district, the size of the file will be more, I think around 200 or 300 MB. So also, so if you don't have the shape file with you, you want to just draw the, you can draw the any polygon or rectangle here. So you can draw a rectangle, suppose here. So as you can see, automatically this geometry has come here. This is the geometry and this is the geometry. Polygon 4 vertices. You can change the name of your, suppose I'll make it ROI. Okay. So I'll, under the import, automatically that geometry came. So if I change all this thing to ROI, here also clip ROI. I have to change here also ROI for downloading. If you want to download. If I run it again, what it will do, I'll switch off this. It will give me the image for that particular area. So either you can draw or you can import your files, and you can, if you run this, it will download and upload this to your Google Drive. So there is one more thing, like I am using this mosaic function because under the console, if you go, also there is an inspector. If you like, you click on any pixel, it will give you the value of all the bands, uh, the NDVI value also 0.58. If you click here, it will give you the NDVI value, and yeah, so you can always check the values at particular pixel. Okay. Also under the console, like this, I have printed this collection, means how many images, total 14 images it has taken between 2nd of March to 10th of March. So you can click here, you can see the dates of the image also. As you can see, this all are 3, 6 and 8. So basically 3 dates are coming here: 3rd of March, 6th of March, 8th of March. So there will be overlap between the images. As you can see here, these are the difference, because but if you use this mosaic one, it will keep on basically putting the image one over the other. It will basically overlay the images, so the latest one will image will come over the previous images. So if your latest image is cloudy, so definitely it will hide the other pixels. So ideally mosaic is not a good option, but if you have very small area, mosaic is a good option because you can get the single date image also. So either you can write here is median, because in mosaic it will take the last operator. If you have mosaic in ADAS Imagine and ArcGIS, so there is option of min, max, last, feather. So it will, in mosaic operator, it will take the last one. So whatever the, it will keep on stacking the images from 2nd to 10th of March. So whatever the last image, if you have overlap area, the last image will come over the previous images. So that's why this difference is coming in this image. So instead of mosaic, you can use median. So wherever the overlap is there, it will create the median image. It will take the median image. Suppose 4 images are overlapping, so it will take the median image of all the 4 images. As you can see, now median is looking much better. Or you can take minimum. Just click minimum, so it will take the minimum images in the overlap area. Like it is looking very good now. Or you can do max, so it will take the maximum value. So what I can do, basically I'll show you best example of this one. Suppose this one, I have already imported the Punjab state shapefile here. So I'll change it to PUN. Go to the Punjab. Yes, the image will be here, definitely, yes. So like if I use directly mosaic and I'll run it, so total 36 images it has loaded, and you can see here there is a cloud. So in the last image, definitely there must be a cloud in the later images. That's why it is coming. Fifth of means. So if you take here median, or such as, like if I take min, definitely cloud will not be there because cloud images are, value of clouds are high. So now it's fine. So it's better to take use mosaic for smaller areas, but for larger areas, either you can use any other option, median image, or you can even go for the mean. Okay, sorry, mosaic spelling, I have made it wrong, that's why. More number of images will come, there is a probability of getting the clouds. like as you can see here in this image, too much of cloud is coming, because in the later images, I think near to this, I think around 18 or 20, definitely they would will be a possibility of having cloud. So either what you can do here, one more option is there, you can use this cloud percentage. If you like do this, so it will take only those images which are having less than 10% cloud. So if I'll run it again, and I'm using the mosaic operator, means last operator, so now the images are 46, and that is very much cloudy now. So if you make it 5%, but your number of images will keep on reducing, only 41 now, but your mosaic will be much better and better every time, like as you can see here. So you can use this also, cloudy pixel percentage, if you want to reduce the cloud. So you can use mosaic, you can, if you write mean, so it will take in the overlap area, it will take the mean of all the pixels. Now it is taking mean. So it depends on you. You want to take, generally I prefer mosaic because, and I prefer very small. I go by district, and I basically try to get images of single date, like such as in case of Buxer. Date 2 to 5. Buxer. And let me go for this date 8 to 5. Okay. So it has now, as you can see, only 6 images came, all belongs to same date. So you get a mosaic of single date image for a particular districts. So you just write mosaic here instead of mean, or you can write mean also, because images of same date, so doesn't matter. So now you got the image using only single date. So I basically check like this. If you're getting very nearby images, so you can use mosaic directly. Or there is one more way to do this. You can use a greenest pixel composite, like I'll show you. This is basically code for that. Same thing I have done, nothing fancy. What I'll do, I'll copy, paste this one. Okay, so same, I'm calling this image this sentinel data bit, and then date, filter means table 10 means here you can write table 9 or anything. Let me go for Punjab only, PUN. Okay, PUN. So then I will print the collection. So this is the function I am running on each and every image between these dates. So it will calculate the NDVI for each and every image inside those dates. Then function, then I am running that function over the whole collection. Dot map NDVI means this collection, and then I am calculating a new function called greenest with NDVI, this one, dot quality mosaic ndvi dot clip table means, and after that I'm clipping it to the area of interest, or you can draw here as I've shown you. Then after that you can create ndvi of that basically that composite. Then everything is same. So I'll run it. So I'll show you what it will do. Basically it will take all the images, 58 images between these dates. It will calculate the ndvi for each and every image, and it will take the maximum ndvi for per particular pixel, and then it will create a mosaic of that composite for the whole area. So you will get the cloud free basically image, image best cloud free, because I basically work in the agriculture area. So as you can see, this, how nice this is looking. So you are getting the fully crowd free data because you are using the maximum ndvi composite. So this is the way to do. Generally, preferably, I use this data for agriculture. So every 15 day I create a composite, and then temporarily you can create profiles of particular crop and all. So between this 2nd of March to 15th of March, it, it took 58 images, created ndvi of each and every image, and then maximum at each and every pixel it has taken the maximum ndvi between that period using this data. So just this is the function, ndvi function. It is mapping over the all the collection. Then dot quality mosaic is a function. Then this is the scaled ndvi. Always you can download here under the task. It is coming for downloading. So either you can go for this quality mosaic, or as I earlier also I told you, a pretty simple one. You can directly, without any this one quality mosaic or greenness pixel, you can either use the mosaic, max, min, mean. That depends on you. So this is the way to download. As I show you, also I'll show you how the data will come in the Google Drive. If you So these kind of TIFF files, as you can see, Sitamarhi 6th March. So file will come under your drive. Then you can download. You can click here, and you can click here download file. You can click on download. The file will be downloaded to your system, and then you can do the further analysis. Also, further few things you can do. You can basically mask the images. You can mask this ndvi, your this one, your images. There is an option of mask also. This is the way to mask. I'll show you. Dot mask, wheat mask. So you, for your ndvi, if you write like this, ndvi dot mask, you upload your wheat mask or any mask uh, into the this asset, and you can import. Like I'll show you. Suppose this one, under the asset I have mask with me. This one, suppose I have this mask. So after importing, this mask has come here. So I'll write copy it. If you want to mask it, let me copy the code from here. Dot mask. So suppose I want to mask my ndvi further. This is my ndvi. A new variable mask. Run this. So as you can see here, this one, it has masked this urban areas. Whatever mask was 0, see here, this one, all this thing has been masked. See, so as you can mask according to your need, forest and everything. And also you can calculate the mean statistics and everything, and you can basically analyze the modis long-term modis data. So in the next tutorial I'm going to show you how to you can analyze quickly the modis data of different season of different years, and you can generate the profiles and statistics. So in the next tutorial I'm gonna show you that. And also you can do the classification, various classification here. Further you can create the samples, and then you can do the classification also. So guys, I hope this video will help you in downloading the data or analyzing the data. So thank you, that's it from this video. I hope and do subscribe the channel if you like the video. Give a thumbs up to this video also.